Now let's take a look at this figure 7-1 from Stallcup's generator, transformer, motor, and compressor book. And notice it gets into the equal number of turns and odd turns and so forth, where you pick up less amperage, less voltage, and so forth. So when we look at equal number of turns, we have equal values. So you see primary winding voltage in amps is equal to secondary voltage in amps, as you see in the illustration. Now, the number of turns, for example, in the primary winding, voltage decreases and amperage increases with fewer turns. In the secondary, we have more turns, so the secondary windings, the voltage increases and the amperage decreases. So this kind of tells you the higher the voltage, the lower the current. The lower the voltage, the higher the current. So we use voltages in a transformer to transform, from one voltage to another, but the kVA stays the same. It's just the amps will change based upon the voltage. Now, let's take a look at where we would have fewer turns in the secondary and more turns in the primary. Now, when we look at that illustration, as I just stated, voltage will increase, then the amperage decreases. On the secondary side now, as the voltage decreases, the amps increases. So, for example, if that primary was 480 volt, and the secondary was 208 volt, then you can see how you're going to have lower voltage, but you're going to have higher current. In the primary, you'd have higher voltage, but you would have less current. And that's what this figure 7-1 is illustrating based upon the turns of a transformer.